so that everything now can be sent to you and you can see the whole thing again if you wish. But, and you will be able at some point just to stop it and just take a photograph or ignore it. You may already have a little map which links all the concepts, which is great, but I'm going to do it here very quickly, okay? I want to just remind you of all the bits and pieces that go into it. You know a lot about RAM or RMM. You know what those are. You don't need to be told. You also have come across the number 6.023 times 10 to the 23. You have come across 24 cubic decimeters, or 22.4 cubic decimeters. This is for gas. These you never have to remember. You don't have to remember them. There is never a need to remember that sodium is 23, carbon is 12, this is an STP, this is room temperature. You never have to remember that. That is always in the question, okay? The thing you have to remember, and I'm not saying that my way of doing it with the triangles is really good. I'm just saying it's one of the ways of doing it. And it's, if you can lock it into your head, sometimes you can go, that's that triangle. And I use 3 colors. And my 3 colors are the colors of the Kenyan national flag. And I do that not to be honorable to you, but I am. But I do it because if I use color, my brain sometimes fits things together and helps me remember. So here are my 3 triangles again, very quickly. If you're new, this may be new. If you've been here before, it's not, but I just want to put it onto this map. So my moles leads me to, the first one is the moles RAM underground. That's the masses one. That's every time we want to work out a mass or a MR or RMM, sorry, RAM, a RAM or RMM or moles, it's this way up. If I have a solution, it is concentration down here. We said it's volume, normally over 1,000, because this is to turn cubic centimeters into cubic decimeters, and the moles are up the top here. The way to remember this, if you thought this was silly, this is the moles, the mole rat, RAMs underground. If I pour the solution, this is all solutions, if I pour it onto the ground, they have to come up to the top, otherwise they drown. And the last one is the gases, and the moles are down here, and this is the 24 cubic decimeters here, and this is the volume in cubic decimeters, okay? Now those 3 are very, very important. All of them lead to the same sets of questions. And the sets of questions go like this. In the first type of question, the most common one is you're asked for the excess. So this is questions. And which one is in excess? This is a fairly straightforward type of question, excess. You're given an equation and you're asked to work out the moles of both of them. I do it visually. I just say, hey, if I've got like a seesaw, a balance, almost always in the questions I've come across, the solid, let's say the metal, is greater than the acid or whatever. Okay? Almost always. In the Kenyan exam, it's that way around. But it's simple. You're working out the moles of the 2. The type of triangles you use here are the green one and the red one. Normally, you've got the green one for this and the red one for that. It's almost always a metal and an acid. Okay? Here's an example. I want you to do this now. Ready? Are you ready? Here we go. Okay, here's the question. The question is, you were given it, I hope, Mg plus 2HCl goes to MgCl2 plus H2. And I have 1.96 grams of this. And I have 100 cubic centimeters of 0.2 mole per cubic decimeter of this. Okay. If you were there in the class early, you may already have done this. Who has already done this one? Who has already done this one? No? Okay. You have, let's say, 3-4 minutes to just do this one, okay? And then I'll ask somebody from one of the centers to go to the board and start it, please.
Good. I like the colors, Mark.
Thank you. They're very, very expensive.
Yeah. Yeah. That's an area in which one of those pens with different colors on it would be useful for the kids, wouldn't it? You know, if they had those, because I like them to use colors as well. And
the difficulty is a lot of these guys won't have 3 colors. No. But I'm going to show them how. Well, I've used shapes around these, and what I want them to do is in the exam use a shape to identify which chemical goes which numbers.
Good, it's good. This looks a bit like Mr. Earth, doesn't it?
This looks like what?
Mr. Earth. No, it's good. Just shows how important, you know, being confident with index multiplication and division is, isn't it? You know, I mean, the maths you get from that is vital for this. You know, your answer is going to be all over the place if you don't know how to.
Absolutely, absolutely.
Apologies, Mark. I had a phone call to take.
That's all right, mate. Oh, Billian are working very actively. St Jerome are looking very, very. I think St Jerome might win this one.
The race.
They look like they're working very, very quickly.
If you're lucky, Mark, the one in the red will give you a shoulder dance.
Yeah. It's so heartwarming to see.
It's brilliant. How are we getting on, Dan? Daniel, are we? It looks like good work to me. Is it good work? Oh, Daniel's off. Michael, how's it going?
Yeah,
excellent. Are we nearly done, Michael?
This is the harder part, isn't it? From when we're teaching normally, just that waiting. 2 minutes.
Yeah. Thank you. Thanks. Michael, Dan, if you have a problem, oh, excellent, we have somebody already. That's very good. If there's a problem, do put it on the chat, please. Oh. That's a shame.
Ah, yeah, they're moving.
I can see it now.
Yeah.
I'm trying to pin his video. Oh, there it is.
Yeah.
When I was looking at the exam questions, there seemed to be quite a lot to do in the time. So if they're asked to show their working in this sort of detail, it would be very hard to get it all done.
I think it might be useful, yes, and there's some idea about what the pass mark is, for example.
That's a good idea.
Or, you know, what grades are. I mean, because as Mark said, you know, I mean, if you're thinking that 50% is a pass and that's what they need, it gives us that time to maybe focus on a better technique with the possibility of not quite finishing all the paper.
Yeah, I think I've seen that somewhere. I can ask Sophia to check it out.
Yeah.
That'd be very useful.
Who I suspect is listening.
And are there different grades? Are there different grades that they need for university? So are we talking about maybe getting plus 70%?
B's plus, B pluses.
Yeah.
No, hugely significant grades.
I will check it out and inform you.
Okay. Thank you, Sophia.
What is the grade that girls need to achieve to get, is it free university place, Sophia?
Yes,
When you have finished writing your answer, please write your name next to it. That would be very kind. Thank you. Only your video has stopped for the minute.
Am I right in thinking it's a C plus, Sophia?
Yes, C plus. C plus.
Oh, it's disappeared. Come on. Yeah. It is so frustrating. For me, it's disappeared completely. Has it for you guys?
No, no. Yeah, I've got it.
Hang on. Pinning.
Rita. Is it Rita? Yeah.
Brighter.
That is excellent work, Brighter.
A lot brighter than you.
That is really good. That is brilliant. Okay, can we guys, can we just try something? Because Brighter did that beautifully, can we have a round of applause for Brighter, please? Really good. Well done. Now, so we're moving on now. Okay, so that is a very common question. Now, I'm only going to give you 4 types of questions. So if we can do each one of these 4 types of question, we can crush this examination. We can make ourselves look really clever. The second type of question was one which I left you with at the end of last lesson. And that's how many atoms? It's how many atoms are there in something? For that, we need the number here, L, 6.023 times 10 to the 23, and you will be given that. Always you're given that. And I sent a question in which said, how many atoms of oxygen are there in some calcium carbonate? So this is how we do it. I normally write it like this. This is the number of moles. This is the number of atoms in the compound. And this is Avogadro's number, 6 times 10 to the 23. So, for instance, if I have how many atoms of H in 1 mole of H2O, then I would be 1 times, there are 2 hydrogens in H2O times 6.023 times 10 to the 23. Okay? So it's a really simple one. If you can just remember this, NXL, whatever, make up some silly way of remembering it. NXL, the number of atoms is the number of moles of the chemical times the number of the atoms in that chemical times the big number. Okay? So let's try one. I'll leave that there just for a minute. I sent one in which asked for how many oxygen atoms in 0.0055 grams of calcium carbonate. So we have to work out the number of moles of this first. Then we look at how many oxygens there are in 1 mole of this and multiply it by the number which you will be given there. Okay? Let's have 4 minutes. Let's have a go. Everybody have a go. Everybody have a go. Even the new girl in the white top at the back of Billian. Bad luck. NXL. So all we need is the number of moles of the chemical and then the number of O's in it, and then multiply that by this big number here.
Not extra large is a good mnemonic.
Not extra large. Well, they are quite small atoms, so that would be a good one. Dan.
You haven't switched off. You've managed to get through without the break, Mark.
I think it's because I logged on using my school account.
Oh, yeah.
Yeah.
You lost it yesterday, didn't you?
Yeah, because I heard Llandovery have stopped paying.
Oh.
I think they stopped last Wednesday, apparently. I've since found out.
So you're going to be carrying on this with Ben Wethig then? Doing the Zoom
Yes,
lesson.
yes, yeah. I wish I could say not extra large.
Yeah.
I'm happy, we're happy to, I think you just pay extra, don't you, to get the more than 40 minutes?
It's hardly anything.
Which, well, I'll pay it. We'll do it. So we don't have this inconvenience.
Yeah, I mean, it's not a problem. It's just, it's
So
just.
Can I do it generally, or how do I go about? Sorry, this is.
To ask Di Rudge, I think that would be the best thing. Yes.
Okay.
You know, he has done to help you on this.
Okay. Well, I'll ring him today and have a conversation with him.
Which centre was Brighter from? Was she in? Was she from St Jerome?
Yeah, I think so.
Yeah,
I think so
yeah.
too.
I didn't know.
It's lovely.
Michael. Michael, there is a gentleman at the front of my view, and there's a gentleman in a blue coat, a blue jacket, lighter blue, and then darker blue. I think he should do this one.
Ooh. Okay. No, it's
Right.
Yes.
Dari and Kabira, and I
Right, so it was from Billian.
you could just observe if you wanted to.
Yeah, she was from Billian, the new girl.
Okay, we'll leave it then. Yeah, no, it's not a problem. No, it's
Is he gonna have a go, Michael?
Yeah, he's going to have a go.
I think he's gonna have a go.
Good.
Hello, I can hear you. The gentleman wants to try. You can try the first question.
It doesn't matter if he doesn't get it right.
Yeah.
No, it's just having a go, isn't it?
Remember, I got one wrong the other day.
Oh, I'd forgotten.
No, I'd forgotten that. Oh, sorry, it must have been Billian before.
Yeah.
Yeah, it was. Brightest from Billian.
Yeah, I saw that now. St Jerome, you better get ready for the next one.
Just
It's funny, every time I try and pin this video, it disappears. Oh!
got it. Yeah, he's got 0 point.
I can't quite. 3-0.
0.00055. 0055.
Yeah.
4 zeros after the decimal, and then
Yeah,
55.
5-5. That's moles.
Yeah. Now he's
So
going
he's going to have to move to another board now.
Yeah. They're good, aren't they?
Yeah.
The way they lay out stuff is really good.
They've been taught well.
They have. It's the maths. It's beautiful.
No, it's just the way they set out the solutions. Amazing.
It's, yes, it's very detailed. Till the video stops.
Mm.
Yeah.
Oh.
I think the video in St Jerome's is better, isn't it? The connection is better in St Jerome's for some reason.
Mm. Well, it comes back in then, that's good.
I don't know. 3.312865 times 10 to the 19. Vincent.
Vincent. Oh.
That's almost like a Van Gogh painting.
Ah, Vincent, that is really, really good. That is really, really good. There's one thing missing. Vincent, hang on, go back to the board. Okay. If you look at the method, which is NXL, what you have got is the number of moles, which was 0.0055 divided by 100, which is right, correct. And then you have, then you've worked out 1 mole is 6 times 10 to the 23. And you've gone, okay, 0.000055 moles times that comes up with your answer. But it's missed out, I think, the fact that there are 3 oxygens. But there's only, that's a 3-mark question. That's only one of them is missing. So that's very good. So round of applause for Vincent, please. Come on, everybody. Let's just look at it. Here we are. Everybody watch here just for a minute. So if this is what I want to do, what I do is here, I work out the number of moles. Well, this is the amount of the chemical I have. So the number of moles is going to be, number of moles of calcium carbonate is going to be 0.0055 grams using the first triangle, 0.0055 grams over the RMM. Calcium carbonate, 40 and 12 and 3/16 is 100, which equals 0.000055 moles. That's the moles of calcium carbonate. I need now to multiply this by the number of oxygens in this. So I go, oh, this is 3. Oh, this is easy. I've got 3 oxygens in each one of these. So I've got this many moles of this, which will be 3 times as many of the oxygen, times the big number. I hope you can see, you can do these calculations in many different ways, okay? But what I want you to get is that there are almost always shortened ways of working it out. We teachers have been looking at your examinations. And in your examinations, if you spend a lot of time working a long way through, you will take a lot of time. So here, what I've done is I've got the number of moles of the chemical, okay? Of whatever chemical it is. Maybe we should do one more. Let's try one more, okay? Let's see if we can get one more. So I'm just going to remove this bit and we'll just try another one. So here we go. Let's try, here's glucose. And I want to know if I have, let's make it easy, 18 grams of glucose, okay? Carbon weighs 12, hydrogen weighs 1, oxygen weighs 16. These are the RAMs, RAMs. So I have 18 grams of glucose. This is this. And I want to know how many carbon atoms. Let's just have a go at this. Just make sure we can do this calculation. So I've got 18 grams of glucose, and I want to know how many carbon atoms are in there. So I'm going to use my number of atoms equals N X L. This is the number of moles of glucose. This is the number of carbon atoms in 1 glucose. And that is 6 times 10 to the 23. Let's just have a quick go at this one. Let's see if we can do this. How many carbon atoms in 18 grams of glucose? Just have a few minutes, just see if we can do that. You will find I have made it easy with 18 grams.
Have we lost St Jerome's?
Well, I think
Dan's still there. Michael and Dan, yeah.
Yeah,
they're both.
We've
I think
lost
they're both there. It's just they've got very low bandwidth.
Yeah, but one of the St Jerome's is gone.
Yes.
Yeah.
that's what's difficult to keep tabs of when you're teaching.
That's what, yeah.
As you alluded to earlier, Sean, yeah?
That's the hard part.
Well, yes, I've got 2 Michaels and one St Jerome, so I'm happy. I look for yellow and white. Well, at the moment, I look for yellow and curtains.
The only thing is, Mark, is that the mobile one isn't in.
Yes, it's disappeared, yeah.
They won't be able to put it on the board for you.
Right. Looks like it's Billian's Day.
Billian's Day.
As soon as somebody has done it, if somebody would like to go to the board and show us, that would be great. But St Jerome, you are, I don't think the mobile is working, so we can't see your board. Unless one of you brought your work up to the camera and showed us it there. That would work.
Yep. Oh, we got a volunteer.
Oh, volunteer. Oh, marvellous.
Shoulder dance.
Yeah, that's right.
That's a sprinter.
Yes, yeah.
Oh, I better do it. Point one.
Well, it's frozen, is it?
Yeah.
Oh, no.
The good thing is it comes back.
Yeah, in just a minute. The answer is 3.6138 times 10 to the 23. Oh, it's come back. Oh, where's she gone? Daniel, can you help our great scientist to get her book to the table, because we can't see your mobile at the moment. Dan, I don't know if you can hear me.
Or is that off the computer?
Yes, I think so. Vincent. Hello, Vincent. Can you hear me, Vincent? You might be called on again. Have you done it, Vincent?
This is Dan here. Dan's looking to. Can you show the work, Dan, to the camera on the computer?
Dan, if you just hold up the girl's book in front of the camera on the top of the computer, then we might be able to see it. Oh, blimey. What happened there?
They've got the hang of this, though, Mark, I think.
I think so too. It's straightforward. The thing is, it keeps on coming up. You just go, well, there we are. There's another 2 marks, 3 marks, whatever.
But it's nice for consolidation.
Oh no, Dan's disappeared completely.
Oh yeah.
Fatma has told me they're trying to log on again with a different gadget.
Okay.
Yeah, because what they were using is really slow. But
Yes,
they're hearing you.
Yeah.
Oh, okay.
You know you're recording, Mark.
Yes.
How do you send it out to Sophia?
Whatever the word is, not translates. It codes it so you can send it in an email. Apparently.
Okay. Okay. I don't know. Yeah. Okay. And where is it saved?
On my computer.
Okay.
I think actually it may be saved in Zoom as well, in which case I can send it via Zoom, I think. But we'll try, we'll just see.
Yeah, I don't know. Yeah, okay.
Oh no, I thought that was for somebody else coming. Nobody yet.
We got someone on the board, Michael.
Well done, Billian. Let's go for it. Oh, Daniel is, hello, Daniel's there. That's interesting.
Daniel's back on.
Yeah,
Michael's
but
doing it.
I didn't get an ask to come back in. Anyway, doesn't matter.
They must do automatic.
Yes. So Billian is in charge again. So let's see what they get this time. Sophia, I have 2 more bits to do. Can I go on till, let's say, 22?
I think so. I think you could.
Okay.
Yeah.
It's good to see you back, Daniel, but your video is still frozen.
Dropped off again now.
Ah, Fatma is just coming in now. Michael, we're a little bit far away. Could you get a little bit closer? Oh, Fatma! Fatma, well done. Oh, competition. Wow. Who is it, Fatma? Who is it who has just done that calculation there?
It's Christine.
Christine. Christine, look at which sugar you have chosen. It's brilliant. It's a lovely piece of work. Which sugar have you chosen?
Sucrose.
Yes, yes, you have. And you're absolutely right that it's 342. The question asked about glucose, which, as you know, is one of the 2 sugars which join together to make sucrose, but that's a brilliant calculation. Well done. Brilliant. Really good. And thank you for being brave. And now let's have a look. Name, please, from Billian. That was really good.
Yeah, excellent.
So, Esther, we've heard from Esther before.
Yeah, last week.
Yes. Nice to hear laughter. That's very good. Very good.
Brilliant.
Well done, and well done, Esther, too, because Esther was right, completely correct, too. So round of applause for Esther. Yes, well done. Seriously, very, very good. Really, very, very good. Okay, Fatma, could you mute, please? Great, thank you very much. Okay, well done. That's very good. Okay. Okay. So the number of atoms equals NXL. What do you say? Not extra large, Sean?
Yeah, not extra large.
Not extra large.
Yeah.
The next, and there are only 2 more of these. The next one, I introduced with a stupid way of remembering it, was I'm Dr. Empirical. Whoops. And it's these 4 here. And empirical formulas always come in one of 2 types. One is where they give you all of the information about the molecule, and the other one, and that's about atoms and about elements, and the second one is waters of crystallization. And we did enough examples of this, but I'm just going to show you very briefly this little bit. So if you remember, I'm Dr. Empirical was produced as a table where we go IMDR, and each of the chemicals goes into one of the boxes at the top. So for instance, I might say, oh, I've got 1.06 grams of Na2CO3 and 1.80 grams of H2O. This is one of those where we have started with some chemical sodium carbonate with water crystals, and we've heated it, and the water has disappeared. And in the calculation, we get these masses, and this is the information which we need. Then it was moles, and I'm going to show you this one because I think most of you did enough examples, and there are some left in the PowerPoint from last time if you want to do more. So Na2CO3 has a mass of 2 times 23 and 1 times 12 and 3 times 16, which is 106. So I've made it simple by going, oh look, here, this is the number of moles. Water has one of 18, and you can see what is going to happen here. If you want to do this, I'm just going to leave up the top bit of it, but you can see what's going to happen here. This is when we divide by the smaller of these two answers here, and we get the ratio, and then we get Na2CO3, this number, H2O, this number. Now, I'm not going to do it here. I'm just going to leave it. So I'm going to leave you with this bit in case you want to do it yourself. I'll tell you that the answer comes out somewhere between 5 and 15 for the number of waters, okay? So you can do that, but that one is, that's the empirical formula. So that's the third kind of question. Do you use FE? Do you use this? Have you used this or EF? Yes, good. Okay. So I think you know this. This is straightforward. The last kind of question is mainly to do with titrations. Titrations are what we call volumetric analysis, and it's a way of finding out something about an acid or an alkali. In Monday's lesson, I said we're finishing moles today, and then we're going to come back to it in 4 or 5 weeks. In Monday's lesson, I'm going to do something about acids and salts and so on, completely away from this, but we will come across titrations, so it links. So in an example like this, this normally has, and you have probably come across the pieces of apparatus, a burette, a conical flask, an acid, an alkali, and this has to have an indicator in it. And this is about these sort of calculations, and it's normally trying to find out something about the acid in your examinations. And the type of acid is normally H3X. Okay? So this is the type of calculation which we have. Now, I just want to show you roughly how it goes. So this is the type, this is all recorded, so you will be able to see it later if you want. So the sort of question we get is 2.5 grams of H3X is dissolved in 1 dm cubed of water. If 25 cubic centimeters is titrated, that just means doing the experiment with the burette against NaOH, it takes 18 cubic centimeters of 0.5 m NaOH. What is X? Now this is really quite a complicated question, when you start it out, it looks more complicated than it is. Let me just show you how it works. They will always give you an equation. And what you have to do to start with is to work out exactly which pieces of information goes with which chemicals. That's the key thing. So if you've got a highlighter in an examination, I don't know if you're allowed to use a highlighter. In the UK we can. Or you can draw boxes around things. The idea is this. So I'm going to put a box around this one and a circle around this one. And then I'm going to look for all the information in here to do with this one and this one. Now, in this one here, I can find it takes 18 cubic centimeters of 0.5 sodium hydroxide. So now I can link these, and underneath this, I'm going to write 18 cubic centimeters and 0.5 m. And they're all to do with the sodium hydroxide. What else have I got in here? Oh, I had 25 cubic centimeters of this. But I also had this and this. So these are going to come into this. So my calculation, I always start with the chemical which I have enough information to use one of the triangles. In this one, it's this. From here, I can use this triangle. And I am always looking for moles first. So I go, okay, here, moles equals, I just remember my triangle, concentration, 0.5, times the volume over 1,000, 18 over 1,000. This will give me the moles. Now, to come over this way now, if you remember what I did at the beginning, I said, oh, this is 1, this is 3. So however many moles I have here, however many moles this is, I need to split it into 3 to find out what this is. It's 3 to 1. Now I'm going to leave you to try to do this calculation, not necessarily get it all right, but right at the beginning of Monday's lesson, I will go through this one before I do the acids and salts and bases, okay? So this is really for those of you who are quite confident, and don't worry if you're not. But it's nearly the time for the end of the lesson, but I thought I'd show you something. So I'm going to get rid of this. It's recorded so you can see it. Okay, I'm in a chemistry laboratory. So I thought I'd show you some chemistry. I've got a chemical here. It looks like water. I'm going to measure out some of it. I'm going to measure out 40 cubic centimeters of it. I'm going to pour it into here. Okay, I'm going to measure out 40 cubic centimeters of this. Different chemical. And I'm going to pour it into here. They both look like water. Nothing's happening. Oh dear. Oh, water and water makes water. Oh. No, it doesn't. It makes ink. That's clever. I've got ink. I want water. Ah, water again. That's good. Okay. I just thought you'd like to see a little bit of chemistry because, you know, we talk about moles and we talk about ordinary, you know, calculations, boring for exam, and sometimes they are really boring. So I think it's quite nice to see a proper chemistry experiment. So that's a proper chemistry experiment, okay? So I will be sending you some pieces, bits and pieces, but it's time to go. I thank very much all the experts who did the work on the board, and you've done well. Try to have a look at all the mole stuff again before we do it in 4 or 5 weeks' time. We will do some questions, proper exam questions, and at that point, I believe you will find you can do moles. In the meantime, it's got back to ink. Why is it ink again? Okay, let's make it water. Oh yeah, that's better. Okay, bye.
Show off.
Bye. Bye-bye, everybody. Thank you very much indeed. Really good. Really good work. Well done. Bye now. Bye-bye. Thank you very much. Bye.
I think that experiment was magic.
Yeah.
It is magic. It's juju.
It's Tommy Cooper.
Yeah, it is Tommy Cooper. Good.
Thank you, guys.
Mark.
Nice for them to see that, Mark, at the end. You know what I mean?
But it's just a bit different, isn't it?
Or you could say that's cheap shots to lure them into chemistry.
I was thinking, how can I do that in maths?
I'll send you the chemicals. You can just cheat.
That was really good. That was good.
Yeah, good.
It was a good lesson, yeah.
Yeah.
It's lovely.
Captures their imagination.
What was the name of the new girl, Sophia? Do you know?
No, I don't know as yet, but I will find out.
Yeah.
Forms so slowly.
Again.
Great, isn't it?
Yeah.
It's great, isn't it? It's like, oh, hello.
Is that how you spend your evenings?
Yeah.
Yeah, I do this at home.
Justin. Hello,
Daniel.
Justin.
Yes, Daniel.
The new students are Isabella Achieng and Eunice Akini.
Daniel, you haven't told them they have to give us a song when they leave.
Isabella and Eunice, eh?
Daniel,
Yeah, right. We welcome
Daniel,
them.
this one's for you.
Oh, wow.
Oh, it doesn't work. Doesn't work
It
anymore.
doesn't change.
Wait.
It should get back to what again?
Magic.
Magic. Juju.
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 Oh. It is Juju.
So, bye.
Bye, Daniel.
Bye, guys. Bye-bye.
That was good, Mark. Really good. Yeah. Enjoyed that immensely.
Right.
Do you want to chat for 5 minutes? Are we okay? Up to you.
I think we're okay. Well, I'm okay.
You were singing and dancing today, you were?
Yeah.
Your cheek
Very good.
stunts.
Stunts. They're not stunts, mate. They're not stunts. It's magic. True magic, right?
Yeah.
So,
yeah.
I think they are working. Sophia, I think you've done a great job. I think the supervisors do a great job. They're working really, really well. And I think if they can get enough practice with the stuff that we're doing, I think they're going to be fine. I really do.
hardworking.
Yeah,
they are.
hardworking.
And they seem to want to learn, which is
Yeah.
nice.
And there were quite a few of them, so it's fine. You know, if it was like 2 or 3, I'd be going, oh, well, I still would have done the ink into water, you know.
Yeah.
I'm only entertaining myself, you know.
We entertained too.
Sorry?
We also entertained by the experiment.
Absolutely.
We don't all have labs at home, do we, Di?
No. I like that though, Sean. It was good reading. You know, that's
Just need to get rid of it. It starts producing some nasty gases.
it's about
Yes,
yeah. But that's teaching, Sean.
yeah, no, that's what it's about.
At its
'Cause
best.
Otherwise, it's just a book, isn't it?
Yeah, that's right.
Yeah.
That's right.
How much do they see things like physics and chemistry laboratories, biology laboratories, Sophia?
Those that come from government-sponsored schools will have laboratories.
Right.
But those that go to non-formal schools do not. They do not have laboratories.
So will
Which will
they
be my
never have
answer.
seen the equipment? Because for people like Di and for me, the equipment is really quite important, you know, for them to be able to visualize it.
Yeah.
Yeah.
So they might not have seen stuff.
They may not have seen.
Okay. All right.
It's like
So
a microscope yesterday.
For you to be aware, I've told Sophia to hold on before making any purchase. I'm going to speak to Brayburn School, which is a little independent school, to see what I can scrounge out of them. So I'm hoping to get some microscopes and anything else out of their laboratories that they may feel they want to dispose with. I'm going to try and get them to dispose it in Challenge Aid's way. So
Brilliant.
So if you can bear with us until I get a response from them, but we're committed to getting you know, at the very least, a microscope for kids to be able to use one, and we'll see what else I can get.